Hello there and welcome. In this lesson, we're going to take a look at inheritance, abstraction, and polymorphism. Together with encapsulation, they are the four pillars of OOP. We already learned about encapsulation with access modifiers, getters and setters, properties. This is just a way to control our access to the data, and this keeps the code more structured. So the first thing we want to take a look at is inheritance. Inheritance is just a way to create a parent class and then have other classes inherit from this parent. This is very similar to interfaces, but instead of having an interface for a specific functionality like the example with the fuel in the previous lesson, where our car can be fuelable but other vehicles, for example bicycles, cannot be fuelable or refueled, so we attach some kind of functionality, some kind of behavior to the interface, and then we simply implement this interface and we enforce this functionality on the class. With inheritance, we have a base class. So for example, we can have this base class of vehicle, and it actually makes more sense to have a base class of vehicle than having an interface of vehicle, because a vehicle is not an actual behavior, right? So we want to have interfaces for behaviors, for different functionalities, and not an actual base class. So a vehicle is a good example for a base class, and then we can have other classes that are going to inherit from this parent class. So for example, we have this class car. And the point of this vehicle parent class is not to enforce some kind of method on the car. It's just a way to have some basic, some general code that is related to vehicles inside the vehicles class, and then the car class can have specific code for the car class. Maybe we also have a train class, and both of them are going to inherit from a vehicle. So to inherit, we are using this colon, and then we specify the name of the parent. Now you can see that this is very similar to the way we implement an interface, but in this case, this is just another class that will be the parent class, and this car will inherit from the parent class. Imagine a father has blue eyes, so the child may inherit these blue eyes from the father, this color. So the car will inherit different data from the vehicle class. Maybe the vehicle class has some public int max speed, because each kind of vehicle will have a max speed. Maybe he will have a public void drive, because each vehicle will have an option to drive. It can also have actual implementation of the code. So unlike an interface where we only enforce a method, here we can actually have a method with data. Now this car class can use all of these without even specifying it inside of the class. So unlike an interface, we don't need to implement them. We can simply access them, and you can see an example here. If I create a class car, new car, I can simply say car drive. So even though we did not implement it inside of the car class, we can still access these because we inherit from the father. So we can use this for different general data that will always be available inside the vehicle class, but inside the car class, we can do something specific to a car. For example, public void park. Right? Because a car can park, but a train, for example, cannot park. It doesn't make sense. The train just goes to the train station, stops there, and then continues driving. So there is no need for a park car or even a park method for the train. So it doesn't make sense to have this as a part of the vehicle class, because then the train will have access to it and it can cause us confusion. There is no need to put this inside the vehicle class because this is not specific to all vehicles. This is specific only for the car. So now the car will have access to the Spark car method, but it will also have access to more general methods that are a part of this inheritance. The train will also be able to inherit these things, right? Now, if the car is inheriting this drive method, over here, the result will be this result, the logic that was inside of the vehicle. Okay, so this is the code that is going to be executed when the car is using this drive method. But what if we want the car to still use this drive method, but have its own logic? For this, we can still use it, but we will have to override it like this, override. And then we have to make this one virtual. And of course, void. So by making this into a virtual method, this can have its own logic. But the car will be able to have its own logic. Okay, now again, it also has to have this void because it's a method. So if we want to override the data and have our own logic inside the car method, then we can simply use this override, and then we also need to make this one virtual, okay? So now over here, when we call this drive method, this is not the logic that is going to be called, but this logic. Okay, so we're actually overriding the data inside the father class or the parent class. If we did not do this, if we just keep this like that and like this, it will allow us to do it, but this code will be ignored. Over here, we would get this logic. So even though we added this method inside, even though we added our own logic, this entire method will be ignored because if we use drive, it will take the father's drive and it will execute the father's logic. And that's something we get with inheritance. So if you have this method inside the parent, it will use the logic from the parent. If you want to also have this method inside of the child, then you need to say override and then have your own logic. Or you can simply remove this and it will use the father's drive. If you have your own logic, you can have it, but you need to have override. So you override the father's data and you also need to make this virtual. And then it's going to allow you to do this. Now we don't use this a lot, but you just need to understand that with inheritance, we have a father class or a parent class, and then we have children. And you can see that this train is also inheriting from vehicle, but we are not enforced to do anything like with an interface. We don't have to use these methods. The train will be able to access these ones, but only if it needs to, only if we want to. We don't have to, we are not enforced to do anything because this is not an interface. This is just inheriting from a parent class in order to have access to the data. And not just access, but actually make this data the data of this class. So then the train will be able to use the same drive or train max speed. Obviously, the train will not be able to use the park method, this one. It will not be able to use it because this is another child. Both of them are inheriting from vehicle, but this is another child. So this other child has its own specific methods, but the train doesn't have access to these methods. It only has access to the father's method, so it will not be able to park. So that's the main idea of inheritance. It's very similar to interfaces, but instead of having some kind of contract with some methods that we should enforce, it will actually have implemented methods, it will have some fields, some properties, and then we can inherit from this class with other classes and have access to this data, or basically to these members. So these members are going to be the members of this class. We can also override them and have our own logic, or we can just remove them and use the logic that is inside of the vehicle class. I also want to mention that with inheritance, we are only limited to one class. So we can only inherit from one class. Unlike interfaces where we can implement many interfaces, and we saw this in the previous lesson, with inheritance, we can only inherit from one parent class, and that's it. Obviously, if we have other parents, we can have other children inherit from them, but each child can only inherit from one parent. Now, if we had an interface here, we can still implement this interface and also inherit from this vehicle class. So maybe the car wants to inherit from the vehicle class and have all of this, but it also wants to have this functionality, maybe some kind of refuel method. So it can simply implement, and the way we implement this is by simply adding this comma here and saying that we want to implement from this interface, but we also want to inherit from this class. So if we have an inheritance, this is the first thing we mention. Okay, so the first thing we need to mention is the inheritance. And if we have any interfaces, we're going to mention them later by using this comma. Obviously, if we have more interfaces, then we can have another comma and add the other interfaces here. But also we need to implement this, so we can quick fix, or we can simply implement the actual method because we have to have this method, right? An interface enforces us to use this method. Again, all of these examples are rather simple, just so you get the point. And of course, things can get a bit more complicated with more complex approaches, but this is the main point of inheritance, okay? So let's just remove all of this and talk about abstraction. Abstraction is something that again is very similar to interfaces. This is just a way to create some kind of structure that focuses on specific things and not on the details. So we expose and we show the things that should be seen, but we hide all the details. For example, if we have some kind of database class and we want to have an option to create different kinds of databases in the future. If you know, there are a lot of different kinds of databases. We have MySQL, there is Firebase, there is MongoDB, like there's a lot of different types of databases. So when we create our database class in our application, maybe we are going to use MySQL as a database, so we can also create a class for MySQL. But what if tomorrow your manager is going to tell you we need another kind of database support? Maybe we want to add a different database support to this application. If you're not structuring your code right, it will mean that you will have to change all the logic that you created with the database class because you have this new class that needs to be adapted. So with abstraction, we can create some kind of abstract database class that will tell us exactly how a database should look, and then we can inherit this kind of abstract class from a different class and implement all of these methods. It can be a bit confusing. It's very similar to interfaces, but for example, we have this class database, and maybe this is the database class that we're going to have in our method. Now, instead of writing all the data inside, because it will only be relevant to one kind of database, right? Maybe this is some kind of SQL database. What if we want to add a support for a database that is not SQL? We will have to add all of this code together and things will get messy and buggy. So we don't want to do this. We want to separate between these layers. We want to have a layer for the actual database interaction, and then we also want to have the logic for the database that will be stored in another class. So for this, we can make this into a database class, but then create another class that will be the specific implementation for MySQL database. So again, this will have all the general logic for the database, and this will have specific MySQL logic. Then we can also have maybe, there is also a database called SQL Server database. So maybe we have different, and again, we can have more and more different implementations of databases, but maybe we want to have support for these two kinds of databases. This will contain specific SQL logic, and this will contain general logic that is related to databases. Now, because we already learned about inheritance, we can simply inherit from this class, and it will basically allow us to have all this data inside of this MySQL database, and we will also have the option to have our own specific logic. Then we can also inherit from this database. So what is the difference between abstraction and just simple inheritance? Well, the difference is that the abstract class is more similar to an actual interface. It will only enforce us to create methods, and it will not provide specific implementation. Otherwise, it's not going to be abstract. Maybe this database class will have some kind of public void connect method, right? Because every database should be able to connect. We should have an option to connect to the database. It means that this one should have this option and this one should have an option, but we don't want to implement and actually give the logic, right? Because it doesn't make any sense. The database class cannot know how this type of database should connect, and it cannot know how this type of database should connect. These ones will have their own logic for connection. So we cannot provide an actual implemented code over here. What we can do is turn this into an abstract method because the class will be abstract. So we make this into an abstract method. Abstract. And then we also need to make this entire class into an abstract class. And now it will basically allow us to implement this if we are inheriting from the class. So it's like inheritance and interfaces mixed together. You can see now this warning, and it tells us that we are not implementing this inherited abstract member, because now, unlike a regular inheritance, this is an abstract class and it functions as an interface. We must implement this abstract method over here. And now we can either click here and quick fix, and it will automatically implement, or not implement, but just add this connect method. Now again, it will have its own implementation. But at least we are going to be sure that this method is going to be implemented inside of this database. Because now, also this one should implement a connect method. So it's like an interface. It's like when we want to make sure this every database should know to connect. Then maybe we also want to have another one. A disconnect, right? Every database should know to disconnect. So these are not optional. Each database must have them. And that's why when we create an actual database, it doesn't matter if these are different databases and maybe the logic is different and they have different implementation, we are going to make sure that they are going to have these kinds of methods. They will know to connect, they will know to disconnect, right? So this one should also implement both of them, and this one should now also implement the disconnect one. So it's like an interface, but just with inheritance, without having some kind of functionality based, but actual abstraction. This is the abstract layer. This is the database. We don't provide specific implementation logic here, but then we create types of databases. We have MySQL database, we have SQL Server, right? Maybe this one have some kind of logic to connect. Maybe we're using some kind of library, and maybe it contains some kind of class. Maybe we have some kind of connect, something that is built inside the MySQL logic, and then we connect. But for the SQL Server, maybe we have something else. Maybe in order to connect, we need to have some kind of API or maybe some kind of web request that is going to send a web request and then connect to this API, right? Because each database can have its own logic, its own connection. Maybe we also have a Firebase database later on, and it will have its own way to connect. So this is abstraction, a way to create some kind of abstract method or abstract class that will have all this abstract data. We must have this connect method. We must have this disconnect. Obviously, we can have more and more. Maybe this connect one should also receive some kind of parameter. And then this one should also have. And as long as we're not implementing this, we're going to get this error, because the connect one should also have a parameter, right? And that's just because we declare this over here inside this abstract class. And why is it useful? As I told you, because, for example, if we have this database DB, we cannot create an object out of it because this is abstract. It will only tell us how to create databases. And then we can create these ones. So maybe we want MySQL database over here. And then we can do all the same, DB, connect. And we don't really care which kind, maybe we need some kind of parameter. So we don't care about the actual class, we care that it's a database. Now, if we want to create another one, we can simply add this reference inside for the SQL Server database. So this is a different kind of database, but we can still do the same thing. Now, here comes polymorphism into action. We can actually use this same data for different classes, although they are not the specific class. So if we want to have a list of databases, and maybe we already have this list over here, new MySQL database. Let's just remove this parameter. New SQL Server database, and we can have more and more databases, right? But we created a list of databases and it contains different types of databases. And we saw this with interfaces as well, right? We could create a list of some kind of interface and then simply store references to these interfaces and do things with them. So now that we have this, we can have some kind of for each database, in databases, we can maybe say database connect. So we want to connect to all databases. And you understand that we are not specifying the specific database over here. We don't care about the specific database. We care about the fact that it is a database. It is this base database, and we can know for sure that it will have this connect logic. It will also have this disconnect logic, and it will have more logic, but we can be sure that it will have this logic inside. So both of them are going to be connected, and we don't really care about the specific logic. We care that it is a database. This episode was kind of rough, but we had to cover these things. So in the next episode, we're going to continue, but you can see that the more this course is progressing, we are getting into a bit more advanced topics. The next topics will be also kind of advanced, but we still need to cover them because I still want to give you some kind of base when this course is going to be over. You may forget some things, but you can always come back here and watch these episodes again if you forget something. The important part is that I wanted to cover most things, so it will not be a surprise for you when you meet them again in another code. So that's all for this lesson. Thank you for watching. Please subscribe if you're still not a subscriber. It will help me a lot. It will keep me motivated to continue with content for this channel. You can also leave a like. You can become a member of the channel and have access to our Discord server that is only accessible for members. There we have one-on-one interaction, and you can ask me more questions, and of course it will support me as well. So I'll see you next time.